Hello everyone, welcome back to the channel. I hope you guys are doing really well. So let's see today's daily challenge on LeetCode and we will solve it together. So let's see and understand the problem statement at first. Maximum total damage with spell casting. A magician has various spells. You are given an array power where each element represents the damage of a spell and multiple spell can have the same damage value. So it is a known fact that a magician decides to cast a spell with a damage of power I. They cannot cast any spell with a damage of power I minus 2, I minus 1, I plus 1 or power I plus 2. Okay, and each spell can be casted only once. Return the maximum possible total damage that a magician can cast, and you must remember that power I can be of the order 1e9 and power of length can be of the order of 1e5. Okay, so you must look to solve it only by n log n or O of n solution. Okay, so let's see how to do it. Now if you see what the problem statement exactly tells you is that if you select a power I, you need to select some elements from this array and add them up and give your answer. Okay, but if you select one element and let's say that element is power I, then you cannot select these elements from the array. Okay, you cannot select these elements from the array. Now you see, if you try to see this example 1 1 3 4, if you would have selected 3, then you cannot select 1 because 3 minus 2 is 1. Okay, power I, if you select power I minus 2 you cannot, and you could not also have selected 4 because once you choose to select 3, power I plus 1 also you cannot select it. So 4 also you cannot select, and therefore if you are selecting 3, then you have to only select that and give 3 as your answer. What is the alternative thing? One thing you can also do is that if you are selecting, let's say 1, okay, now if you are selecting 1, let's say take both of the ones, because why to leave the other one, right? So you just take both of the one and add them, becomes 1 plus 1 2. But now you see, you selected 1, you cannot select 3 now. Okay, so because 3 is 1 plus 2, so if you select power I, so power I plus 2 you cannot select. But hey, you can select 4, right? Because 4 is 1 plus 3 and it's not told anything about that. So what can you do exactly is that you can simply select 1 1 and 4 and you can add them up to get 6, and that will be your answer. Okay, so I hope you do get to understand something from this. And one observation which you can easily get is that if there are duplicate values in an array, just take all of them. Why wait? Okay, so what can you do is that, let's say if your array is something, let's say very big, okay, and you have this 5, this 5, and let's say this 6 6 6 6, a lot of 6 are present. Okay, and let's say you have some 7s, something like that. Now if you see, if you are selecting 5, you cannot select this bunch of 6 also and this bunch of 7 also. Okay, so might be you need to traverse a lot in the array to actually find, let's say something like 8 or 9 which you can actually select. So what you can do is that you can make some another array, you can make another vector which will give you the value. Let's say 3 5s are there, 5 6s are there, and 3 7s are there. There is no dot dot over here. Okay, so how will I save this kind of array? I will, let's say, save it in the form of a vector of pair. Okay, why I am doing it? Because to shorten the array, because the unique numbers only matter, right? Otherwise we have to traverse a lot. So you select 5 and the value corresponding to 5. So if you select 5, take all of the 5, why leave the other ones, right? So you select 5, then you take the value of 15. Okay, and then if you select 6, you take the value 30, right? If you select 7, then you take the value 21, right? So if you try to see, if you try to go on seeing these types of stuff, if you have only a single 4, then you can simply keep 4 and 4, because well, it occurs only a single time. So what you are doing is that you are actually shortening the array by a lot. You see how many elements were there in this array? 1 2 3 4, and 4 plus 5 is 9, and plus 3 is 12. Okay, so there were 12 elements in this portion of the array. Now you have reduced that to 1, 2, 3, 4 elements only. So you see now traversal will be a lot easier and you can directly refer to these elements, and you see you do not even need any binary search or anything like that using this trick. Okay, so what you can do, if you are selecting 5, you do not select the numbers which is next to it and next to next. Now you might be thinking there might be a number 8. Okay, and so you check the value, right? If my number next to me is lying within 6 or 7, then do not take it, otherwise take it. So we can do some things like that. Okay, and now if you see I can choose to, now if you see this problem has only unique elements in our array right now. Okay, so we are going to have only unique elements and our array is also shortened. So what can we do? We apply a take not take DP here. Okay, so now if you don't know anything about this form of DP or this form of recursion and memoization, so I have taught DP from very basic to advanced in my playlist. So you can just go into my channel and see under the playlist, you will get DP from very basic to advanced. Okay, and I am continuing that playlist till I am on DP on strings topics, and I am going to soon add a video, next video also. So yeah, you can just follow that, and this topic I have clearly and in detail explained this. We can apply the same thing over here. Whenever you go on an element, you can just choose to take or not take, and we will start with a recursive solution at first, and which will definitely give you a TLE or an MLE or whatever, and then we will go on for a memoized solution, which is will also be accepted, which will actually be called a recursive DP. Okay, which is also called a recursive DP, and you can definitely convert it into an iterative DP for interview purposes, but for online examinations you can ignore this iterative DP, as these recursive DP is also acceptable in most cases. And if you have practiced a lot of problem, then you can directly go on writing this iterative DP. Yeah, so things will come into your mind, but in this today's problem, I will assume that yeah, you have like not that uh, practice in DP. So I will just go through both the recursive and the memoized solution. So what we can do is that it's very simple. First I will create this vector of pairs and I will just go on. Okay, so I will just first create this vector of pairs. So I have an n which will give me power dot size. Let me keep a vector of pair integer comma integer, which will which is, let's say I will name it array, and what I can do, I can go through all the elements. Okay, and what I can do also is that let's say pick an element, I will name it power I, definitely it is power I, and I also have a value which is initially 0, and I will keep adding this value. So I will just tell that let's say it should not go out of bound, and the main thing is that while power of I is equals to this element, what you can do, you can keep adding this element to the value and keep incrementing I also. So after this you must do I minus minus, because you see I plus plus will happen only in the next iteration. So there will be a time when you are doing I plus plus 2 times, which you do not want. So yeah, you can do this, and what you can do also is array dot push back this pair, because we are pushing the pair this element comma value. Okay, so you can simply push back this pair and you are done with creating this vector. Okay, you have created this short vector, and you can simply write a recursive function which will give you the answer. Okay, so what you can do is that you can tell me from where to start. So I will start from 0, and I will just start from this 0 index and keep on analyzing, and whether to take not take this, take not take this, take not take this, and so on. Okay, so I will just do that, and I will just also pass this array. Okay, so let me write another function which will be nothing but func. Okay, and I will write an integer, let's say I am keeping it short, and it will be vector of pair of this array only. So yeah, I can just copy this and write arr. So what can I do now? I can write the base case. So first thing in recursion is always the base case. So when my pointer, I am in this I am starting from this pointer, okay, I equals to 0. When I will reach the last element or reach something greater than that, that is my base case, that return 0 in that case, okay, because you cannot do any damage. If you are in this cell, let's say, you can choose to take or not take. If you choose to take, you will do this amount of damage, right? That's it, that is the concept. So if you are exceeding the array bounds, you cannot return anything. So if array is greater than or equals to, let's say, n, and n I will define here. So int n is nothing but array dot size. So if this happens, what you can return, you can simply return a 0. So yeah, that's what you can do. And you see, now you can choose to not take or take. Okay, so I will first take select for the not take case. So now what if you are not taking, deciding to not take this element? Okay, so let's say this element you are not taking and your eye is pointing towards here. Okay, so you will simply increment your pointer to I plus 1 and look for the next element, right? So you will simply recursively call this function and you will do I plus 1, you will add the array and do nothing else. That's not taking, right? And if you want to take this, what you will do, you will go to the second element of your ith index. Okay, you will go to the ith index and pick up the second element and add it. So what can you do it? Array of I dot second, pick up the second element and add it. So you add it to what? You recursively call this again. So once you have taken this, you can now go to the next element again, right? Even for the take case. So yeah, you can go to the next index, but once you have taken this, you must remember, let's see, you have taken 5, then you must remember you need to jump these 2 elements, at least 2 elements, or maybe you don't need to jump anything. Okay, so you can just assume that is j. I will show you how to calculate j. Okay, so I will write some function which will write something which will actually calculate j. Right now, how you can exactly do it? Let's say I will use a for loop for this j to be I plus 1, starting from I plus 1, j less than n, j plus plus. If you get something like if array of j dot first becomes greater than the array of I dot first plus 2, then what you can do, you can break from this loop. So you see, what I am trying to do is that I will keep on iterating j, and I will see whenever this j pointer. So you see, I will start j from j, I will initialize j as I plus 1 as I have done here, and I will keep on iterating until I get some value, let's say 8, which value, the value array of j dot first, that value should be greater than this array of I plus 2. Okay, so array of I dot first plus 2. So if that is happening, I can choose to take this element as my next iteration in my as my next recursive call. So I can just choose to break it, and you can realize easily that this loop will not go more than 2 places, because all are unique numbers, right? Now the array is very short and everything is the numbers are really unique. So at most it will jump 2 places, 5, 6, 7, or maybe one place 5, it directly gets 8, or maybe 2 places 5, 6, 8. Okay, so 5, 6, 7, 8, or 5, 6, 8, or maybe 5, 8. Just I hope you do understand what I'm trying to say. So yeah, that's why this loop works here. It does not give any TLE, because this loop runs for at most 2 times. You could have used simple if statement also, but yeah, if you are understanding the concept and using, then there is no harm at least. So yeah, you do get the j, you do get this, and what you can simply do is that for the current iteration you are telling that maximum, take the maximum among take and not take, and return it, simply return it. So if you try to run this code, I guess it should work perfectly fine. Okay, so you see, I have taken test cases, one test case I have taken which is very long purposefully. So yeah, one thing which I need to do here is that, let's say I will just cancel this, and I will hash define long long also. Okay, hash define ll long long, and I will try to convert most of my things to long long, right? Yeah, so I have it. I just am converting most of the things to long long. I guess you do understand it. So yeah, these three integers also I need it in the form of long. So yeah, that should work. And if you try to submit this, I guess you should get a TLE, because this is a recursive solution. It has an exponential time complexity, because 2 to the power n should be the size. Okay, so it is also giving you a wrong answer. Okay, so you see, I forgot to sort this vector. So yeah, the first thing is that this vector I assumed is in sorted order, which may not be the case. Okay, so definitely what you need to do is to sort this vector. So yeah, sort power dot begin, power dot end. So yeah, if you try to submit it, let's see what happens. You see, you get a time limit exceeded, which was quite obvious because you are following a recursive solution. You have not yet done any recursive DP or something like that. So yeah, what you can do is very simple. You can create a cache memory type of thing for recursive DP. Uh, it will be a simple linear DP. So because you have only one argument, one state of the DP, right? So it is a simple linear DP, and it will be of the size array dot size, and all the values should be initialized by -1 initially. Okay, and you can simply pass this DP as your function and pass it. So -1 simply denotes that right now it is empty. Okay, so it simply denotes that it is right now empty, and so you have it, and you can write vector dp here also. And what else can you do? Yeah, now the time comes to catch it. If you have seen this value before, so if it is not -1, implies that I have filled this dp before, and I do not need to do this whole thing again. I am saving my time, so I will just simply return this dpi. Otherwise I will calculate this whole thing, and at the end do what? I will save this state in my dp, max of this take comma not take. Okay, so I will just save the whole thing in my dp, and yeah, that's all I guess. You can just return this. So not return dp, return dp of I. So yeah, I hope you do understand how this catching is exactly working. It is also known as recursive dp, and this actually does great. Okay, uh, for getting accepted, I don't think you even need to do it in iterative DP, but yeah, for your practice purpose, you should definitely do convert it into iterative format also. So yeah, I do get a wrong answer right now. So let's see what is the error that I did, or what improvement can be done. So yeah, we have this if dp of I is not equals to -1, return dp of I, and you initialize this dp to your array dot size. That's correct, and you simply pass this array as your next element in the dp. So yeah, I am definitely missing out something. Let's see. Okay, so I do understand what I was doing. Mistake is that I forgot this integer to be converted to long, right? So yeah, that needs to be done. I think this is only the error, but let's see if there is still some mistake. We will see it again. But there should not be. Yeah, so you see there is no further mistake, and you get a decent runtime and memory complexity also. So yeah, I hope the approaches are clear to you, both the recursive and recursive DP solution. I will give you the task to convert it into iterative DP. If you don't know how to convert it, just go to my DP playlist, okay, and watch the first few videos. There I have in detail explained how can you convert a recursive solution to an iterative solution. And yeah, do not ignore this, because the interviewer may ask you definitely. Okay, because see, it reduces the space complexity, not the time that much, but I hope you do understand that that is also important. Although this always gives accepted, but whenever you are doing a DP problem, you should also write the iterative solution. Okay, so yeah, that's all. I guess that's all. That will be all for this video. Keep coding. I will see you in the next video. Till then, thanks a lot.